Hello guys, welcome to my lecture series of digital electronics. In today's video we are going to discuss about some binary operation. So there are fundamental 4 arithmetic operation: addition, subtraction, multiplication and division. We will look forward for each and every operation one by one. But before starting the content of today's lecture, let us have the solution of my previous video. So previously the activity was to find out the equivalent binary, octal and hexadecimal of given decimal number 196. Second, find the same binary, octal and hexadecimal number equivalent to 243 decimal, and third 1008. Okay, so if you apply double method over here, then you can find this answer. So 196 can be represented as 11000 in binary, 304 in octal number system, and C4 in hexadecimal number system. Similarly, 243 can be represented as 11110011 in binary, 363 in octal, and F3 in hexadecimal number system. By doing the same procedure, 1008 can be represented as 111110000. So total 10 bits will be there in binary number system, 1760 in octal number system, and 3F0 in hexadecimal number system. Okay, now let me show you a very interesting relationship by which you can convert any binary number into octal or hexadecimal and vice versa. Fine. Now for this discussion we will consider these last three columns of binary, octal and hexadecimal. See, the radix of binary is 2, radix of octal is 8, which is nothing but 2 raised to 3, correct? And radix of hexadecimal system is 16, which is 2 raised to 4. Here I can write 2 raised to 1. Now this power shows that the group of 3 bit of binary number is equivalent to 1 bit of octal number, correct? And this power 4 means the group of 4 bit of binary number is equivalent to 1 bit of hexadecimal number. Okay, so the important point from this discussion is, let me write down over here, group of 3 bits of binary number is equivalent to 1 bit of octal number, because 8 is 2 raised to 3. Okay. Second point is group of 4 bits of binary number is equivalent to 1 bit of hexadecimal number. So these 2 points are very important as far as the conversion is concerned. So if in any exam they ask or they give you the binary number and ask you to find the octal or hexadecimal number, then you must perform the streamline method on binary, then you get the decimal equivalent number, and then you convert that decimal into octal or hexadecimal by double method. Fine. So these 2 steps will involve in your calculation. The first step is the streamline method, which will convert your given binary into decimal, and then you will use double method to convert that decimal into required octal or hexadecimal. But if you are aware about these 2 points, then your calculation will be very less and you can directly convert any binary number into octal one. So here I am having one binary number 11000100. So what will I do? If I want to convert it into octal, then I will make group of 3 bits. I will make group of 3 bits. Here 1 bit is missing, so I can add 0. And I will write the equivalent decimal of every group. So 100. So 100 here, 2 raised to 0, 2 raised to 1 and 2 raised to 2. So 4 into 1 4, 2 into 0 0, 1 into 0 0. So I will have 4. Then 0 0 0, again 2 raised to 0, 2 raised to 1, 2 raised to 2. See, we have taken the base common as 2, which is the radix of binary. That is why 2 raised to 0, 2 raised to 1 and 2 raised to 2. Okay, so we will have 0 and 0 1 1. So 2 raised to 0, 1 multiplied by 1 1, 2 raised to 1, 2 multiplied by 1 2, 2 raised to 2, 4 multiplied by 0 0. So 2 plus 1 will be 3. So in this way you can directly convert any binary number into octal number by taking a group of 3 bits. Okay, now if you want to find equivalent hexadecimal number, then what will you do? You will take the group of 4 bits. So for next number, say 243. So to convert the binary 11110011 into hexadecimal, what will you do? You will take the group of 4 bits. So here 2 4-bit groups are forming 0011. So this is 2 plus 1 3, 1111. So 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to 3. So 1 into 1 1, 2 into 1 2. So 2 plus 1 3, 2 raised to 2 4 multiplied by 1. So 4 plus 3 7, 2 raised to 3 8 multiplied by 1 and 8 plus 7 is 15. But in hexadecimal we represent 15 by capital F. So as you can see, we can directly convert the binary number into hexadecimal one. Okay, now you just perform the same exercise on this binary number and verify that by taking the group of 3 bits, either you are getting 1760 or not, and by taking the group of 4 bits, whether you are getting 3F0 or not. I am sure you will have the same answer. Okay, now let us start the discussion for today's topic, that is arithmetic operation. So as we discussed, there are 4 arithmetic operations: addition, subtraction, multiplication and division. Now for addition purpose, it is beneficial to remember this relationship. So if A and B are 2 binary numbers, then we will have 2 parts. One part is called sum, another part is called carry. So carry is something that may transfer to the next bit. Okay, so if 0 plus 0 is performed, then sum will be 0 and carry will not generated, so carry will be 0. If 0 plus 1 is performed, then sum will be 1 but no carry will be generated, so carry will be 0. If 1 plus 0 is performed, then sum will be 1, carry will not be generated, hence carry will be 0. If 1 plus 1 is performed, then sum will be 0 and carry will generated, which is 1. Okay, now how can we say that this is true? See, because in decimal and in binary, so in decimal 1 plus 1 is 2, correct? In binary 1 can be represented as 1, this one can also be represented as 1, but this 2 is represented as 1 0. So LSB is the sum and the next bit is carry. So here as you can see is 1 plus 1, but in binary the sum is 0 and carry is 1. Then for subtraction, there are also two parameters. One is difference and second one is borrow. Fine. So borrow is something that we should keep from the next bit, and it will not goes to the next bit. Okay. So if we have 0 subtracted from 0, then difference will be 0 and no borrow is required, so borrow will also be 0. But if you want to subtract 1 out of 0, then it is not possible because 0 is less than 1, so we need to take borrow from the next bit. So difference will be 1, but borrow will also be there in this operation, so borrow will also 1. Then 1 minus 0, obviously difference will be 1 and no borrow is required. 1 minus 1, difference will be 0. In this case also no borrow will be required. Okay, so let us have some examples in order to have the better understanding. So my first example is regarding addition. So we are asked to find 110 110 10 plus 101 So both the numbers are in binary number system. So what will be our first step? My first step is to write both the number so that each bit will match each other. Okay, here this is very important. The bit should be matched. It should not be written randomly. Now addition or any arithmetic operation will always start from LSB. So doing so we'll have 0 plus 1, so the sum will 1 and carry is 0, so here carry is 0. For the next bit, 0 plus 1 plus 0, sum is again 1, carry is 0. Then for the next bit operation, 0 plus 0 plus 0, it is 0, carry 0. Then 0 plus 1 plus 1, here 1 plus 1 is introduced, so sum is 0, carry is 1. It is very important. Then 1 plus 1 plus 0, again 1 plus 1 is there, so sum is 0, carry is 1. 1 plus 0 plus 1, so again sum is 0, carry is 1. 1 plus 1, sum 0. Here nothing is there, that means you can consider 0 over here. Okay, so 1 plus 1, sum is 0, carry is 1. Again 1 plus 1, sum is 0, carry is 1. Here nothing is there, that means 0 can be considered, so 1 plus 0 plus 0, and you will have a bit overflow. Okay, don't worry about that word bit overflow. Okay, so this is the addition of 110 plus 101001. Now if you want to verify this, see, then you can also verify. The multiplier over here is 1 2 4 8 16 32 64 128 and 256. Okay, so the first binary number is equivalent to 2 plus 8 10 plus 16, so 26 plus 64, that is 90, plus 128, so the first number is 218. Okay, the second number is 1 plus 8, that is 9, plus 32, so which is 41. So if you take addition in decimal number system, then 218 plus 41 will be 259. Now if you convert this 259, then let us see what is our sum in binary. So it is 1 plus 2 plus 256. So 256 plus 2 plus 1 will again give you 259. Okay, so in this way you can easily verify your answer whether it is correct or not. Okay, Now moving for the next operation, binary subtraction. So what is the first step? First we will match the bits and we will write each bit just below the first operand. Okay. Now 1 is to be subtracted from 0, which is not possible, so this 1 will be borrowed over here, so it will become 1 0. Now 1 0 minus 1 will give you 1, so and this 1, because it is borrowed to the next bit, it becomes 0 now. So in the next operation, 0 minus 0 is 0. In this 0 minus 0 again 0. 1 minus 1 it is 0. 1 minus 0 it is 1. Then again 0 minus 1, which is not possible, so we need to take a borrow. So we will take a borrow from immediate next bit, and that is 1 0. Now 1 0 minus 1 is 1, and this 1 has been taken as borrow, so it will become 0. 0 minus 0 is 0, and last 1 minus 0 is 1. So this is how we can perform the binary subtraction. Okay, now if you want to verify whether the answer is correct or not, what can we do? Again we will have the same trick. We will convert each binary number into decimal one and then perform the subtraction so that we can verify the answer. So 2 plus 8 10, 10 plus 16 26, 26 plus 64 plus 128, here 128, yeah. So this number is 218. The second number is 1 plus 8 plus 32, so that is 33 plus 8, which is 41. And if we subtract this 41 from 218, you will have 177. Okay, so let us verify that if the final binary number is equivalent to 177 or not. So you will have 128 plus 32 plus 16 plus 1. So 128 plus 32 plus 16 plus 1 will give you 177. So both these answers are matching. That means our calculated difference is correct. Next, multiplication. See, multiplication and division are very easy process because the only possible answer is either 0 or 1. So we will first match the bit, then we will start with LSB. So for this LSB, we will multiply this whole number with 1. So we will have 1 0 1 1 0 1 1. Then for this bit, we cannot define the 0 power of radix, so we will put x in this place, and if we multiply this number with 0, then we will have 7 bit with 0 value, 3 4 5 6 and 7. Okay, then the last bit, that is 1, so we cannot define 2 raised to power 0 and 2 raised to power 1. Okay, so finally we will start our multiplication from here, and if we multiply this number with 1, then you will have 1 0 1 1 0 1 1. And now we will perform addition. So here 1 x means nothing is there, so addition is 1. 0 plus 0 0, 1 plus 1, sum is 0, carry 1. So 1 plus 1, again sum 0, carry 1. 1 plus 0 plus 0 plus 1, sum 0, carry 1. Now this is interesting point because you have not come across such kind of situation in which you will have 1 plus 1 plus 1. So actually when you have decimal 1 plus 1 plus 1, it is 3, but the binary equivalent of 3 is 1 1. Okay, so your sum will be 1 because LSB is a sum and all the other bits are carry. Okay, so 1 plus 1 plus 1 will have sum 1 and carry also 1. Now for this addition, 1 plus 1 sum is 0, carry 1, 1 plus 1 sum 0, carry 1, 1 plus 1 sum 0, carry 1. So we got 1 0 0 1 0 0 0 0 1. Now let us verify whether our answer is correct or not. So for that, what we will do, we will simply write the increased power of radix, that is 1 2 4 8 16 32 64 128 256 512. Okay, so our first number is 2 plus 1 4 4 plus 1 5 5 plus 8 13 13 plus 32 plus 64. So our first number is 109. Our second number is 4 plus 1 5, and if you multiply 109 by 5, then you will have 545. Now let us check whether we are getting it or not. So this is 1 plus 32 plus 512. So as you can see, this is 512 plus all these things are 0. The next addition will be 32 plus all these things are 0, and next addition will be 1. So 512 plus 32 plus 1 will be 545. So in this way you can verify whether the calculated answer is correct or not. And lastly, the binary division. So what we will do, for binary division, we will do like 1 1 0 1 1 1 0 0 divided by 1 0 1. So very first you will decide whether, see, if the quotient is possible, then it will always have 1, and if it is not possible, then it will have 0. Okay, so the very first time it will be 1, so you will have 1 0 1 over here. Then you will perform subtraction, so you will have borrow over here, you will have 1 0 0. Then after that the next bit will come down, so 1 1. Now this 1 1 means 3 and 1 0 1 means 5. So 3 is less than 5, so we cannot have any rule. So we will have 0 0 and subtraction will be 1 1, and the next bit will come down. So we will have 1 1 1, which is 7, and 1 0 1, which is 5. So 5 is less than 7, so our quotient in this case will be 1. So 1 0 1. Again subtraction. See, next bit will only come down after we perform subtraction. Okay, so 1 minus 1 0, 1 minus 0 1, 1 minus 1 0. Now the next bit will come down and it is 1. So you can have 1 over here, so 1 0 1, and you will have 0 0 0. Now this next two bits are 0, so it will simply come out at quotient, and this is our final answer. Now see whether this is correct or not. So 1 2 4 8 16 32 64 and 128. So our first number is nothing but 128 plus 64 plus 16 plus 8 plus 4 is 220. and this 101, obviously it is 5, so 220 divided by 5 is 44. So if we convert this binary, our quotient is 10110. So 1 2 4 8 16 and 32. So it is 32 plus 8 plus 4, so you are getting 44 over here. Okay, so both the answers are matching, that means our calculations are correct and up to the mark. Okay, I want you to practice this arithmetic operation as much as possible, so that you will be aware about different situation. Now, as a practice, I am giving you these 4 examples, one for each arithmetic operation, and I hope you will try to solve it. Please write your answers in the comment box so that we can discuss about the authenticity of your answer. Thank you.